Hi, here is the presentation of our paper Assessing RAG System Capabilities on Financial Documents. This work combines ITIA's academic expertise with UBS, one of the leading global banks, to address industry-applied AI challenges. This initiative is part of the long-term partnership under UBS ITIA AI Lab. There are three reasons that motivate our research. The first one is the need of the financial institutions, which process thousands of documents that require human interpretation. And thus, being able to automatically handle this document would help them. The second one is that actually there are a lot of challenges because such documents have data which are hard to process by the existing systems. Indeed, the current LLMs show limitation in quantitative reasoning and cross-document synthesis, which are essential for financial application. Lastly, there is also a lack of evaluation framework, and evaluating the performances of the system on this task requires a specialized benchmark. In this paper, we present FinDoc RAG, a RAG-focused question and answer benchmark over heterogeneous financial documents. We evaluate several RAG architectures and try to find their individual strengths and weaknesses in handling financial content, and this should help to promote transparency and innovation in AI, especially in the financial domain. FinDoc RAG is a question and answer benchmark comprising of more than 600 Q&A pairs coming from 46 documents, all in English and created by real bank institutions. It contains various types of documents, including, for example, product descriptions, but also marketing material, or even research and reports. It also contains different kinds of complex features, which makes it ideal for RAG systems evaluation because it reflects real-world financial complexity. The collection of documents is divided into two distinct subsets. The first one contains concise fact sheets with dense numerical content. The second one contains comprehensive reports with complex layout. The questions are structured across 9 complexity levels from 0 to 8, targeting 3 different task types: factual extraction, information integration, and multi-document synthesis. Each level introduces specific constraints. The levels 0, 1, 4, and 5 involve single document retrieval tasks that require direct text extraction. The levels 2 and 6 require combining information coming from multiple document sections or sentence fragments. It may require mathematical operations, numerical comparisons, or logical synthesis of related concepts. And the levels 3, 7, and 8 integrate cross-document information and require reasoning across multiple sources. A human validation has been conducted on a maximum of 50 randomly chosen questions per level using annotators with financial domain expertise. This evaluation reveals that most levels have a high correctness rate above 80%. Our objective is to identify which RAG approaches achieve sufficient accuracy on the benchmark and to uncover the limitation of these approaches. We thus evaluate 4 representative RAG systems, which each correspond to a distinct architectural approach. The first system is called vector RAG and is a baseline method. It relies on an index of dense vector representations. All documents are encoded into high-dimensional embeddings. The submitted queries are also encoding using the same model. For retrieving, documents are ranked based on their vector similarity to the query in order to determine their relevance. Then the top K documents are used to generate the answer. The second system, called Raptor, is a semi-structured method based on a hierarchical summarization organized on a tree structure. The documents are broken down into smaller chunks, themselves being grouped into clusters. Each cluster is then summarized by an LLM. The process is then repeated to build a tree with multiple levels of summaries. For the retrieval part, the tree is traversed layer by layer, and the nodes are evaluated to find the most relevant information. The third system is GraphRag, a multi-step method. It first creates a graph-based index by building an entity knowledge graph and generating summaries for groups of related entities. These summaries help to create partial answers when a question is asked, and they are then combined into a final response. The last system is GFM-RAG, a query-aware graph neural network. It is pre-trained on more than 60 knowledge graphs. We create a knowledge graph by prompting an LLM over the source document. Then, when a query is submitted, the GFM retriever model is then used to extract relevant entities. The 10 entities are selected and used by document rankers that retrieves a ranked set of relevant documents that are used to answer the query. To assess the quality of the responses, the results using LLM Judge reveals distinct performances according to the architectures. Raptor happens to be a robust general system. GFM-RAG is the strongest performer. It achieves perfect accuracy on level 3 and leading performance on level 6. Vector-RAG is a good baseline. It excels at level 2 and level 3, but decreases on synthesis tasks. Graph-RAG is rather deceiving. It has strong capacity on basic tasks, but severe degradation on complex synthesis ones. When looking at the results, we also noticed distinct performances according to the type of task. For the factual extraction task, there are stable performances except for GraphRag on level 4. For the information integration task, there is a substantial variability which suggests system-dependent capabilities for intra-document synthesis. And for the cross-document synthesis task, there are large ranges of performances which highlight fundamental architectural differences in multi-document reasoning capabilities. Our results revealed that the level of the task complexity resulted in different models' performances. Indeed, for the factual extraction tasks, which are rather easy, there are always scores which are higher than 50%. For the information integration task, the results are more variable, which suggests a system-dependent capability. For the cross-document synthesis, a hard task, it shows a large ranges of performances and highlights fundamental architectural differences. More generally, our results highlight the strengths and limitations of the system and shows indeed the need that there was of benchmarks like FinTech to measure the progress towards more reliable financial document understanding systems. In our work, we assessed 4 state-of-the-art RAG architectures using FinTech, and our results reveal that the architectural choices have an impact on the performances. We are also sharing our benchmark, which is made of heterogeneous financial documents with structure complexity levels, and in the future, this benchmark should be used in order to guide the selection of systems based on specific use cases. It should also help to measure the progress in financial document understanding. Thank you for your attention.